There we go. Hopefully everybody can hear me here. Aloha mai kako. My name is Christopher Wegner. I serve as a hazard mitigation specialist for the Maui Emergency Management Agency. It's a real honor to be up here today to speak about the Maui Method. By the end of this, I hope to answer a few different questions for you. What is a MEMA guy doing up here talking about batteries? What is the Maui Method, and how do we use the Maui Method at Ukumehame wildfire project last year? So the genesis of this is our wildfire risk reduction program. This is a coordinated, data-driven, and all year-round program that focuses on the highest risk areas. And the objective of the program is very simple but critical: to reduce the intensity, the frequency, and the destructive nature of wildfires through practical land stewardship, proactive vegetation management, hazardous fuels removal, and ignition prevention. As part of this program, we conduct risk assessments of county-owned and managed lands. Last year, we identified 42 acres of county-owned land in Ukumehame at mile marker 13.5 as an extreme wildfire risk. This parcel had tall hazardous fuels, 20-foot plus opiuma, an invasive species of trees, and extreme ignition risk sources there on the site. As you can kind of see in the map in that zone echo area, during initial site visits, we discovered a cache or a plethora of electric vehicle batteries. In the end, we discovered 13.3 tons of both lithium-ion batteries and nickel metal hydride, as well as 21 EV and hybrid vehicles that still had the batteries remaining in them. At that time, we knew that this represented a hazard. We didn't quite know the exact type of hazard or the risk that it presented, and so we brought in a Maui native, a subject matter expert on lithium-ion batteries and hazardous waste. And that sort of started our journey off. That individual introduced us to a lot of subject matter experts who have been dealing with lithium-ion batteries for a number of years, including a co-chair of a lithium-ion task force at the U.S. EPA, federal on-scene coordinator, as well as the state on-scene coordinator of the Department of Health at the Hazardous Evaluation and Emergency Response Office. And this sort of was the crux of our team, this county, state, and federal partnership that led to the successful mission that we had. We also had vital input from our fire department, other county departments, including Public Works, Environmental Management, Mayor's Office, Management, and Corp Council, and then vital support from our private partners. At Maui County, we had VARA's contracting, agent security, and the state had their hazardous waste technicians from PENCO come in that provided vital support. And this was the crux of a beautiful collective partnership that led to us using the Maui Method and addressing this hazardous waste in Ukumehame. Very quickly, I want to go over some battery basics. A lithium-ion battery is considered a rechargeable battery. There are non-rechargeable and chargeable. Regardless of chemistry, every battery has four components. You have the anode, the cathode, the separator between the two, and the electrolyte that allows for the flow of ions exchanging. There are different types of lithium-ion batteries. You can see prismatic, cylindrical, and pouch. Lithium-ion batteries have taken over the global energy storage market, and there's a reason for that. They outperform old battery types in a variety of different ways. They're low maintenance. They charge quickly, they last a variety of charge cycles, they store a lot of energy for the amount of little weight and size of the battery itself. They're in every application, large to small. You're in your large storage systems, your electric vehicles, all the way down to your cell phones, your toothbrushes, your AirPods. They're in your tools, they're in your e-bikes, your e-scooters. They're in a lot of consumer products and electronics. In parallel to that, the increase in cell failure resulting in a cascading effect known as thermal runaway and thermal propagation is also increasing. When the battery goes into thermal runaway, it is an unstoppable event. There is no type of foam that you can apply, no amount of water that will extinguish a fire or a thermal runaway event. And what happens is a release of a chemical cocktail of both flammable and toxic gases, including heavy particulate metal like cobalt, nickel, manganese, and aluminum. Lithium-ion batteries are a technological breakthrough, but they absolutely deserve our respect and careful management. Lastly, I want to point out that end-of-life batteries are typically regulated by RCRA, but damaged defective batteries to transport and to handle then become subject to RCRA's hazardous waste management under 40 CFR and 49 CFR. And so for our Ukumehame project, I want to strictly say that the Maui Method was born from the Lahaina wildfires. There are a lot of EV batteries, hybrid batteries, charging stations in the homes that became hazardous waste. This was later refined in the LA wildfires of 2025. For our Ukumehame project, we received a first-of-its-kind emergency hazardous waste permit. I want to state that clearly. This type of permit to conduct this type of method on this type of hazardous waste has never been issued anywhere in the country until this mission that we performed. And we conducted this last year. We did initial site visits in June, but the crux of the work and the operations happened between August and November. And early November, we culminated with 2 showcase days where we brought in partners from all over the state to show them our site and the method itself. And on the screen, you can kind of see the layout of this. We have our different containment work zones laid out there. The red area, the exclusion zones, roughly 120 by 120 feet. You can see there we have our brine tank area in the number 13 area, a crushing pad in number 14. Number 16 is our excavator that's used to crush the batteries. And so this is a site layup. It's a very functional site, which I'll get to more in a moment. A little delayed. So I want to go over what the Maui Method is and go over the different steps. So I want to highlight first that this is a flexible method. And even at our Ukumehame site, we didn't exactly go in this exact order, but this is usually the exact order you want to go in. So first is the treatment site setup. This is basically setting up your 3 containment site work zones that you saw on the previous slide, your exclusion zone, your contamination reduction zone, and your support zone or your cold zone. And this is basically us setting up these zones, putting signage up, containment, access control points. We basically want to ensure that all people and all equipment are in the right place where they should be. And this is done to reduce or minimize risk and maximize health and safety from day one. The next step is the battery removal inspection. We actually did this first at Ukumehame because of how we were doing our order of operations. We had, as you can see in that map in that zone echo, we had hazardous fuels surrounding the cars and the batteries, and we had determined or had set on to basically move the batteries to our actual site across the street in order to get away from the ocean and to maximize the use of open space in that area given the prevailing winds there that go Mauka to Makai. But this next step is battery removal and inspection. So every battery has to be inspected. You're looking for damage, you're looking for punctures, you're looking for swelling of battery packs, you're checking voltage all over. When you're removing batteries from a vehicle, you're doing inspections. Depending on the type of car, in the picture here you can see a car on its side and the battery kind of flapping out. That's a Nissan Leaf. The battery packs are underneath the vehicle. If you were to take a battery out of a Toyota Prius, you have to go inside the car. It's in the back seat. So depending on the type of vehicle, you're doing a different operation. And again, I want to highlight that at every step, you're reducing risk. You're thinking about, okay, how do I prevent these batteries in a thermal runaway? This step is to inspect, reduce risk. Ideally, you're handling as little as possible. You're transporting or moving as little as possible. And you're not unnecessarily stacking batteries in a way that's potentially dangerous or going to put that battery at risk of thermal runaway. The next step is the most popular step, and it's the stabilization and discharge. This is where we take the batteries and put it into a brine solution. We had 3 tanks on our site because ideally when you place the battery in the brine solution, you want at least 24 inches of water between the battery and the top of the surface. This is basically, you can use a variety of different solutions in there. We use salt and baking soda. Very simple and cheap. The salt's used to facilitate discharge in the water. The baking soda is used to stabilize the pH and prevent corrosivity. And this is basically done, you want to discharge the cell, you want to de-energize the battery pack, you want to control the heat that comes off of this, and you want to be able to basically control how the gases and any heavy metal coming out of the battery is contained within the solution. So once that is done, typically you're also looking at deconstructing the battery. You've reduced the energy. I want to also state that the energy will never go to zero. You can take voltage readings, you can say zero, but you always assume there's still stranded energy in the battery pack itself. It will never go down to complete zero. And so you carefully, with HAZWOPER trained individuals and electricians and mechanics, go through and start breaking the battery down. You're taking electronics apart, you're trying to rip the circuitry that connects all the battery packs to each other. And so you go to the next step, and that's the mechanical crushing and pulverization, and that's essentially where we take the excavator bucket and a thumb, and you're basically splitting these battery packs apart. You're separating the anode and the cathode from each other, thereby eliminating any of the chemical activity that defines a battery. And so that can also be done a second way. You can also use a metal shredder, as long as you're getting the cell pack down to its cell pouch, and it's just aluminum housing covering that the anode and the cathode. So the next step is your monitoring and stabilization. So the next thing we're doing is we're putting it in a UN-rated 55-gallon drum. This needs to be ventilated so that it can off-gas appropriately. You do not want hydrogen building up and causing an explosion, which has happened many times when people are transporting these batteries or this not battery material. At this step, you're dealing with what is considered not battery material or battery debris, or it's sometimes referred to as black mass. And so once it's in the drum, you're basically checking for temperature, doing thermal imaging, you're monitoring air quality, and making sure that the temperature of that barrel goes down to ambient conditions. And you're making sure that it's safe for transport. And you usually want to keep it in there on site for about 7 days as you're monitoring this. The next is we're always going to do a sampling and get characterization on a material. You're sending pieces into a lab, you're checking for toxicity, corrosivity, ignitability. You're using the T-clip method to test for the different RCRA 8 metals. And this is our receipts to determine to help transporters, shippers, disposal facilities, and recyclers to understand what it is that they're accepting or transporting. And lastly, there's the final management and disposal of the battery debris itself. Again, you can see in that picture we have an elbow PVC in there, and that's to prevent any water from coming in. There's off-gassing. The container we have that you see in that picture is open top, but it's got this sailing material that allows for breathing and off-gassing while preventing any debris or water getting into the container. And so we're basically documenting this. This has to be, because it's still under RCRA being managed as universal waste and hazardous waste to some degree, it's got to be monitored. We got to have our paperwork in order. We got to fill out the manifest right, work with the shippers, work with the recyclers and disposal facilities to make sure it makes it safely to its final disposal facility and placed somewhere where it's actually safe. And so that's kind of the nuts and bolts of this method, the 7 steps. And again, this is a flexible methodology, but it's still a risk-based methodology. At each step, you're trying to reduce the risk of thermal event runaway. We have health and safety plans in place per OSHA requirements. Again, all people are HAZWOPER certified. We have twice daily medical checks, safety meetings, hot washes at the end of each day. Everybody's wearing proper PPE, open air conditions, monitoring wind direction, continuous air monitoring of gases. We have a water buffalo on place and a fogging nozzle in case of an emergency, 24/7 site security, primary and second containment of brine tanks. MFD and MPD were on site or at least notified of what we were doing at all times. We had contingency plans in place in case of thermal runaway. All the not battery material, again, is in a vented drum and container so that gas buildup does not occur. And we monitor and inspect these drums for at least 7 days. So that is the quick of the Maui Method. And now I'm looking at some Q&A. Thank you for listening to that. I want to quickly say that we have a YouTube videos, documentaries, a short and long form that goes over the Maui Method. It's on the Maui Emergency Management YouTube page, so please go to that and check out our work there. Let's see here. So I have a question. Is Maui considering controls on where electric vehicles can be parked or stored? I am not aware of that, that sort of measure being taken at this time. I'll quickly state that we're having a lot of catch-up to do in terms of regulations, laws, and policies. Even at the state level, it's not very clear as to how to handle this sort of material or deal with electric vehicles. And is reconditioning of any of the batteries for secondary storage applications a consideration? This is a loaded question. There's no way I can give this due justice in the next few seconds. I'll just say there's a difference between end-of-life batteries and damaged, defective, recall batteries, and that distinction is not very clear. And that is something that, if you're looking into what to do with batteries, you need to answer that question first. Thank you so much, everybody, for your time, and wish you a great conference. Thank you.